Right, today we're going to look at section 12.6, which is the binomial theorem. Also, we'll use the Pascal's triangle. They kind of go hand in hand together. So we're going to use the Pascal's triangle to expand binomials and find some certain terms. So first thing is just a little information on the binomial theorem. You guys can read through this, but Pascal's triangle, the triangle is an array of numbers named after a French mathematician, last name being Pascal, which is where it comes from. Things to know about the triangle: the first and last numbers of each row of the triangle are 1, and every other number in each row is formed by adding the two numbers immediately above it together. So you can always make the triangle. You don't have to remember it as long as you remember these two key pieces of information. So for Pascal's triangle, looks like this. So our first row, we just have our 1, and then we're just going to go down. So you're adding, every single time you're adding a number. Notice it's always 1's going all the way down right here on both sides. This 2 is formed. 1 plus 1 is 2. Here, 1 plus 2 is 3. 2 plus 1 is 3. So we can fill in, because here we know this is going to be a 1 on the end. 1 plus 3 gives us 4. 3 plus 3 is 6. 3 plus 1 is 4. Same thing here. Add again. 5. You can just continue to do these adding. So our last row, we know we have to start with 1, then we add our two numbers, 6, 15, 20, 15, 6, and 1 again. So if you forget the triangle and you have to expand, which you're going to have to expand depending on the row, you could make this little triangle to figure out what our coefficients are, because we're going to need these numbers that are in these rows when we start expanding. So have those filled in. So Pascal noticed the numbers in the triangle are precisely the same as when we expand a binomial. So that's why we're going to use, you can use Pascal's triangle, or there's a bunch of formulas you could remember for expanding the binomial. So you're going to be asked to expand binomials that look something like this. Remember, a binomial to a 0. Remember, anything to a 0 power is 1. That's the top line of the triangle. If I'm expanding a plus b to the 1, that's just 1a and 1b. Notice that's the second line of our triangle. If I'm simplifying or expanding a squared term, a squared plus 2ab plus b squared. Notice these numbers, 1, 2, 1, are what's in the triangle we just did. So if we had it cubed, again, notice it's not the third line, it's actually the fourth line, because our first line goes with 0. And then we could do this for our to the fourth. We have our fourth one, 1, 4, 6. It's always one row down in your triangle. To the fifth. And then we are going to use these numbers as our coefficients, and then whatever our a and b are, we just fill them in. Notice the a, which is the first one in our expansion, starts and it has the fifth, the largest exponent, and then the a to the fourth, it just goes down by 1, so our last term doesn't have 1. The b, the second thing, starts the other way. I don't have it in the first, starts with 1b, then b squared, b cubed, b to the fourth, b to the fifth. So we're going to use this information to expand our binomials instead of multiplying them out, which is a lot of work. So notice the top row of Pascal's triangle is called the 0th row, just because anything to the 0 power is 1, like I just talked about. And then the next row is our first row, because it goes with a plus 1 to the first power. And then any row after that, we're just calling it the nth row. The nth row, depending on which one we are looking at as we're going through things. So we're going to use this triangle to expand some binomials. Few things that you can look for. These are in your notes, but watch for these things. The number of terms is 1 more than the power of the expansion. So if my power of my expansion is squared, I have 3 terms at the end. If it was fourth, I have 5 terms, and so on. The coefficient of the first term and the last term is always 1. Okay, before we simplify. After we simplify, it might change. The coefficient of the second term and the next to the last term is n before we simplify again. And the sum of the exponents in each term is whatever n is. Notice those are always before we simplify, which you're going to see as we do examples. So let's look at an example. We want to use Pascal's triangle to expand each expression. So I want x minus y cubed. So in our expansion, if you look at your notes up there, there's an a and a b. So let's figure out what a and b are. So a is always our first thing. So our a would be x. So a is x up here. Our b is always our second term. Notice it's negative y, because in our expansion, we always did a plus b to something. So our a is our x, our b is negative y. we want to cube it. So that means we look at the fourth row in our triangle, or look at your a plus b cubed, and notice that a plus b cubed from your notes above looks like this. So 1a cubed, 3a squared b, so forth. So what we need to do now, everywhere there's an a and a b, we need to substitute what our a and b are. So everywhere there's an a, I'm going to put an x. Everywhere there's a b, I'm going to put a negative y. So if I plug that in, so instead of a cubed, I have x cubed. Instead of a squared, x squared. Instead of the b, I put in the negative y. Now we need to simplify this. Simplifying it is a key. So if I simplify this, well, 1x cubed, usually we would just write that as x cubed. Here, 3x squared times negative y. This is like having a negative 1 in front of your y. Multiply the numbers. 3 times negative 1 gives me negative 3, and then I have an x squared and a y. Okay, so that's good to go. Over here, my next term, I have a 3x and I have negative y squared. Well, if I square that negative y, if I square a negative, it becomes positive. So this becomes 3x and then it's y squared, because when I square that, it goes away to positive. Whereas this last one, if I square this, remember it's like a negative 1 if I cube it, sorry. If I cube negative 1, if I put in my calculator negative 1 cubed, I'm going to get out negative 1. So this becomes negative y cubed. So sometimes we might have positives. This would be our final answer right here. Okay, let's look at another one. This one I have x plus 2 to the fifth. Well, again, let's figure out what our a and b are. So our a is always our first one, so our a is x right here. Our b is our second one. Since it's plus, it's going to be positive. Our b is 2 this time. It's not a variable. That's okay. Find your fifth row to figure out what our coefficients and variables are. So if we look at our fifth row, it looks like this. Notice the coefficients in red right here with the 1, 5, 10, 10, 5, and 1 are the coefficients from Pascal's triangle. This again has the a's and b's in it, so now I need to substitute in what my a is, which is x, and my b is 2. So everywhere there's an a, I'm going to put an x. Everywhere there's a b, I'm going to put a 2, so that's what I have next. Might need to pause to fill in. Now we're going to simplify. Well, x to the fifth, I already kind of simplified that. I didn't write the 1. Here you multiply the numbers together. So 5 times 2 is 10x to the fourth. I only have one variable in my problem, so I'm only going to have one variable in my answer this time. This time I need to take 10 times 2 squared. Well, 2 squared is 4. 4 times 10 is 40x cubed. Here I have 10 times 2 cubed. Well, 2 cubed is 8, so 8 times 10 is 80x squared. 5 times 2 to the fourth. 2 to the fourth is 16. 16 times our 5 is, where am I at? 720 x. And then, oh wait, that is not right. 5, 10, 40, 80, that's not 720. Scratch the 720 right here, it's 80 again. Don't know where I got my 720. And then 2 to the fifth is plus 32. So this would be our answer. Only one variable in my problem up here, only one variable in my answer. Sometimes you might have 2, like our first example, sometimes only 1. So let's do one more of these. So 3x plus 2 to the fifth. So again, what's our a? Our a is whatever's first. So our a this time is 3x. It's a number and a variable. That's okay. Our b is going to be 2 again. I'm doing the fifth power, so a plus b to the fifth, our a and our b right here. And then we need to multiply that out. So add in. Everywhere there's an a, we're going to put 3x. Everywhere there's a b, we're going to put 2. So that's what I've done next. Again, you might need to pause to write it out before we start simplifying. And then we're going to simplify. So if I look at this, this 5 has to come to the 3 and to the x. So 3 to the fifth is 243 x to the fifth. My next one, this 4 has to come in here to the 3. So what I'm really going to have here is this 5 times 3 to the fourth times 2. I have to multiply all the numbers together. If I take 5 times 3 to the fourth times 2, I get 810 x to the fourth. So our next one again, I have a 10 times, this 3 has to come in, 3 cubed. This time I have times 2 squared, so I need to multiply all these together. If I multiply all those together, I get 1080x cubed. Then our next one, again, I still have that 10. This time the 3 is squared, the 2 is cubed, so we multiply that out. Use your calculators. That gives me my 720x squared. This one, I have 5 times the 3 times 2 to the 4th. So if we multiply all that out, I would get 240x. And then plus 2 to the 5th is 32. So this would be our answer. Okay, so that's expanding. You're going to have some of those on your homework. That's a large portion of your homework is that expanding. So the next thing we're going to do, your example 2, requires us to find a term that contains a certain x to the 5th or whatever our is. So you need this. To find a general term, you need this formula. So if you're given a plus b to the n, you'll have some numbers in there. This is what we're going to use to find a term. Okay, and we're going to talk about how to get, this is not, the n and the r right here is not division. It's actually called n choose r. Okay, no division sign. In our calculator, we're going to do this. It's NCR. Okay, so for example, in your calculator, to get to this, so that you know how to do this, because it's the easiest way to do it, you're going to hit Math. You're going to go over to Prob, and then you'll see a button that says NCR. And then whatever our numbers are, we'll plug them in. Okay, so if you need help on the calculator, make sure you're coming to see me. So we're going to use this formula for our next example. So example 2, find the coefficient of x to the 5th. Sorry, that should not say find the coefficient. This one wants us to find the term that contains x to the 5th and the expansion of 2x plus y to the 20th. I'm actually going to do what your directions say, not mine. So if you think about what our formula just was, it was n choose r, and then it was a to the r and b to the n minus r. So we need to figure out what all these letters are. So our a, again, is always what's first, so our a is 2x. Our b is what's listed second, so our b is y. And then our n is 20, it's whatever's right here, 20. And our r is what we have right here, our x to the 5th, it's going to be 5. Okay, so now what we're going to do is we're just going to substitute in what we get right here. So this is going to be 20, choose 5. Our a is 2x, so we're going to put it in parentheses, 2x to the r, and our r is 5. B to the, oh, whoops, no, I don't want just the b right there. Let me erase that. Erase, maybe erase. Okay, so then my b is y, so this is going to be y to the n minus r, which is to the 20 minus 5. So now let's figure out what all these are. So first let's figure out what this 20 choose 5 is. So in your calculator, we want that NCR button. So what I would do, type in, I'm going to put exactly what you need in your calculator. You're going to type in 20, then you're going to go to the Math button, to the Prob button, choose the NCR button and hit Enter. And then when it pops up, you'll hit 5 and hit Enter again. And you should get the number, where's my number, 1,500 or 15,504. So this 20 choose 5 is 15,504. If you need calculator help, see me. Then I have to bring this 5 in. 2 to the 5th is 32, and then that's x to the 5th because it has to come into both of these. And then this would be y to the 15th. Don't really need my parentheses. So now we need to multiply these two numbers because multiply are big numbers. So our final answer is going to be 496128, x to the 5th, y to the 15th. Okay, questions, see me, especially if you can't get this in your calculator. Okay. All right, moving on to our last example. I'm actually going to change this a little bit. It says find the coefficient of x to the 8th in the expansion of x squared. I'm going to make this is actually a really difficult problem. I didn't realize till I had already made notes. So let's change this to x squared, and let's just make this a 1 right here. So we're going to change this to x squared plus 1 to the 10th. So your notes say just find the coefficient, which means I don't care about the variables, I only want the number, but we're going to go ahead and use the whole thing. So remember, it's n choose r, and then a to the r, b to the n minus r. So let's figure out what we have. Our a is x squared, our b is 1, our n is 10, and our x is, our r is 8. Okay, so now looking at this, we have our n choose r, so 10 choose 8. Then I'm going to have x squared to the r, which is x squared to the 8th. Our b is 1 to the n minus r, which is 10 minus 8. So we need to do in our calculator, see if you can get this, 10 choose 8. I'm doing this right along with you. I just made this up real quick. Is 45. This, remember, you multiply, so x to the 16th, and 1 to any power is just 1. So I have 45x to the 16th, but then it only wants the coefficient. So if all it asks for is the coefficient, you just give the number. Our answer would just be 45 right here. Okay, so I changed that last example. I'm not going to give you any that hard on your homework. If you have questions on something, please come in and let me know.